Okay, so here's another video in our series of how to write a 20-marker videos, and lots of you have been asking for one from the hazards topic, so here we go. Just a quick reminder of the mark scheme before we go through and mark this one here together. It's a really good one. So firstly, we are going to need good knowledge of the key concepts and processes, so we're going to call that CP. And then we also need case study in our 20 markers. In addition to that, we're going to need a good detailed conclusion, evaluative conclusion. We need to write in a evaluative fashion throughout, so that's going to be EV. And then a couple of little tricky ones. So we need synopticity, so some links to other areas of geography. So we'll call that SYN. And then finally, we need some awareness of temporal or spatial scales in the answer, so we're going to call that TS. And I'll code the answer up as we go through it. And then as you know, at the end, each one of these gets a level. So 1 is very limited, 2 is some, level 3 is clear, and level 4 means detailed. So we're basically looking to do all 4 of those things in a detailed way, and that gets us 20 out of 20 if we do that. So here's the question. The impact of earthquake hazards depends primarily on human factors. To what extent do you agree with this view? Okay, so let's go for it. The subsequent impacts from earthquakes to a partial extent depends upon how well prepared and planned humans are for such hazards. So here we go, to a partial extent, I'd say they're already evaluating. So that's a little evaluation there. Nice. It could be argued that humans play a large role in minimising the impacts of earthquake hazards. So large role, evaluation. The impacts of earthquake hazards, as countries such as Japan have the technology to invest in life-safe structures. So a bit of case study there mentioning Japan. Not specific yet, but that's good. Seismic isolators, counterbalances and cross bracings help to keep structures from pancaking and the PNS wave strike. Wow, so seismic isolators, concepts and processes, all those different techniques. Pancaking, concepts and processes. PNS wave strike, understanding of concepts and processes in geography. Fantastic. Okay, where are we up to? Despite the magnitude 9 earthquake off the northeast coast of Japan in 2011, life loss from the earthquake was very small and few buildings collapsed. Wow, so good case study here. And they're kind of evaluating because they're arguing their point here, so a bit of evaluation there as well. Tragically, the buildings in Port-au-Prince, Haiti, were not life-safe. When the magnitude 7 earthquake hit this island in Jan 2010, 180,000 homes collapsed, 1.5 million were made homeless, and 1 in 3 buildings collapsed. I think they meant to make people died here rather than buildings collapsed, and then 1 in 3 buildings collapsed. The ad hoc building built rapidly to cope with rapid urban growth contributed significantly to the heavy death toll of 230,000. So contributed significantly, that's great evaluative style writing, and more case study there. Clearly the evidence suggests that human factors can play a significant role in the subsequent impacts of earthquakes. So they've gone back to the question, which is a really nice link back at the end of the paragraph, linked all the way back, and that's great evaluation. Here's the second paragraph. Conversely, it's important to recognise that the impacts from earthquakes may not be solely attributed to humans and their preparations. So great evaluation of introducing the other side of the argument. It is important to recognise that physical factors such as geology and morphology of earthquake areas can increase the subsequent impacts of seismic events. They're giving the other side of the argument, and a bit of concepts and processes on geology and morphology. Liquefaction is a key hazard from earthquakes and is more likely to occur where geology is soft. So a bit of concepts and processes on liquefaction, and they're arguing here, so good evaluation. Haiti's underlying rock is weak. Where are we? Haiti's underlying rock is weak, and liquefaction caused the port in Haiti to subside, restricting the arrival and importing aid from abroad. So a good case study there. Japan's 2011 earthquake generated a 10-metre tsunami. Towns along the northeast coast were affected differently due to the morphology of the coastline and the refraction of the waves. Towns like Ofunatu, Sendai and Miyako were heavily inundated as the seafloor was so shallow with few headlands to protect the towns. So a bit of understanding the concepts and processes, fantastic case study there, and they're evaluating this argument. Over 12,000 were killed and 400 kilometres of coastline dropped by 1 metre. Wow, great case study. Despite sea walls and tsunami warning sirens, the physical factors played a key role in the impacts from these earthquakes. Right, so going right back to the question again, fantastic. And another tip here, guys, this person's written beyond the space, and that's a superb thing to do. And you might have noticed before, down the bottom, they've got a plan. Always write a plan to your answer. You can pause that back there if you want to see the plan. Okay, here's the conclusion, or maybe a last paragraph. One final reason highlighting the importance of human factors is preparation and planning for earthquake. On the 1st of September every year, the Japanese carry out earthquake drills. So a good case study there. Children experience earthquake simulators, and emergency services rehearse their life-saving procedures. Early warning systems in Japan detect the S-waves from earthquakes and can provide valuable seconds for people to drop, cover, hold, or get outside. A brilliant case study, and also concepts and processes again with S-waves and drop, cover, hold. These strategies did not occur in Haiti and may have contributed to the 230,000 deaths. Some more case study there. In conclusion, so we're looking for a detailed conclusion now, earthquakes cannot be prevented or predicted. Humans can mitigate the hazards if they have the technology, funding and government support, says their conclusion. Despite man's best efforts, some physical factors cannot always be prepared for. More conclusion. The magnitude, scale, depth of focus and location of the earthquake can be unpredictable. Good concepts and processes. This unpredictable nature of earthquakes is what makes managing them such a challenge for the future. And a bit of a look to the future there as well. So it's a bit of temporal spatial scale there. Okay, I haven't marked in the temporal spatial scale very well there because they've got great contrast between Japan and Haiti, which is really strong temporal scale. So in every paragraph, I think the examiner would be thinking a bit more about Haiti and Japan. The contrast between those is great spatial scale difference between an LIC and an HRC there. So let's go back to these. Concepts and process is very strong, so it's level 4. Case study, ridiculously good, level 4, so it's detailed. Conclusion, is it clear or detailed? I would say it's detailed, so level 4. Evaluation throughout, level 4, so it's detailed. Synopticity, are there links to other areas of geography? I think we'll go level 3 for that one. Could they link it to anything else in urban? Did they write about rapidly built urban growth perhaps? Yeah, so here there's synopticity, but we'll maybe stick with high level 3 for that one. And the last one, temporal spatial scale. So spatial is really strong with the contrast of the two. Temporal, could they talk about the future a bit more? So we'll go level 4, probably low level 4 for that one. So overall it's level 4, and this is like a 18, 19, something like that.